Good morning, friends. Today we are going to study the next point from the GOC, that is the stability of resonating structure. In the last lecture, we saw the points to draw resonating structure, means how two resonant structures are drawn. Isn't it? Different concept points. Now, stability of resonating structures. What is the necessity of to know the stability of resonating structure? Now, see here. If consider a case, general case, A double bond B C have positive charge. C have positive charge. Now this is the resonance condition, resonating condition, general condition. A double bond B C have positive charge. Resonance is possible in this case. Resonance is possible. But if we draw the resonance, in this case, if we draw the resonance, that is the like this. If I draw the resonance, then what happens? A single bond B double bond C, at the same time A has positive charge. A had positive charge. Now in different resonating structure, different atoms in that resonating structures carries different charges. Different charges. Now see in first case or in this first case, and suppose this is second case. In first case, the A double bond B C have positive charge, isn't it? Means C point carries positive charge. C atom carries positive charge. But at the second structure, A atom carries positive charge. Even these are the two resonating structures. Even these two are resonating structures. But their contribution to the real structure is more. Out of these two, which one is more stable? That decides the more contribution, more shares to the real structures out of these two. Now ABC, they are the difference, but C atom positive, here A atom is positive, isn't it? And C and A, these two atoms are different. So that's why we have to consider the stability of out of these two, stability of resonance structure. For that purpose, we have to consider some points that helps to decide the stability, and after stability, that is the final product of that particular reaction. Now first point, considering stability of resonating structure, first point, that is the neutral molecules are more stable than charge separated structures. Neutral molecules are more stable than charge separated structures, isn't it? म्हणजे कुठलाही चार्ज नसणारा मॉलिक्यूल जर असेल तर त्याची स्टेबिलिटी ही चार्ज सेपरेटेड स्ट्रक्चर्सपेक्षा जास्त असणार. एक एक्झाम्पल बघूया. डबल बॉन्ड suppose if I consider in first case, and if we see the resonance in this case, then like this double bond, positive charge, negative charge. This is second case. Now in these two structures, which one is more stable, which one is less stable? That is the first point. Neutral molecules are always more stable than charge separated structure. That's why first case there is no any charge on atoms, isn't it? In that molecule, no any charge. But in second case, positive charge is here carbon, negative charge is here. It is charge separated structure. So out of these two, first consider is more stable than second. First structure is more stable than second structure. This is the first point. Second point. Now, resonating structures, the stability as far as concerned. Resonating structures are more stable if the structure contains large number of sigma, actually not sigma bond is concerned, because almost in all resonating structures sigma skeleton is same. It only differs with the pi bonds, that is we saw in the last lecture, that is points to draw the resonating structure. That's why pi bond, that is the large number of pi bonds असणारा structure is more stable than molecules with less number of pi bond. म्हणजे ज्या मॉलिक्यूलमध्ये लार्जर नंबर ऑफ पाय बॉन्ड्सची संख्या जास्त आहे त्याची स्टेबिलिटी जास्त, त्याच्यामध्ये कमी पाय बॉन्ड्स आहे त्याची स्टेबिलिटी कमी. दॅट इज द फर्स्ट. हेच एक्झाम्पल जर घेतला, सी फर्स्ट केस अँड आफ्टर रेझोनेटिंग, negative, this positive. See, Just sigma bond, if you observe, then 1, 2, 3 sigma bonds are 3. Here 1, 2, 3 sigma bond is also 3. But if you observe pi bonds, here 2 pi bonds are there. 2 pi bonds are there. But here is a 1 pi bond is there. 1 pi bond is there. Ultimately, that's why first structure is more stable than second structure. First structure is more stable than second structures. Isn't it? Now third point, that is the molecules, that is resonating structures. Molecules with or resonating structures with complete octet is more stable than resonating structure with incomplete octet. म्हणजे ज्या रेझोनेटिंग स्ट्रक्चरमध्ये सगळ्या ॲटम्सचे ऑक्टेट कंप्लीट आहेत असा जास्त स्टेबल आहे इनकम्प्लीटपेक्षा. दिस बेस्ट एक्झाम्पल, सपोज CH3 CH पॉझिटिव्ह चार्ज, ऑक्सिजन CH3, here lone pair. Now if you observe carefully the structure, no matter in this case the electropositive atom carries negative charge or electronegative atom carries positive charge. हा पॉईंट पुढे येणार आहे. म्हणजे जरी कंप्लीट ऑक्टेट असणं हे जास्त महत्त्वाचं आहे. ऑक्सिजन किंवा नायट्रोजन किंवा असे इलेक्ट्रोनिगेटिव्ह जे आहेत त्याच्यावरती जरी पॉझिटिव्ह चार्ज त्या मॉलिक्यूलमध्ये स्ट्रक्चरमध्ये दिसत असलं किंवा जे इलेक्ट्रो पॉझिटिव्ह जे आहे त्याच्यावरती जर निगेटिव्ह चार्ज आला तरीसुद्धा डोंट बॉदर अबाउट दॅट. जस्ट लुक अबाउट द whether octet is complete or incomplete. Now here if you consider this structure first and whether resonance is possible. In this case, just for what we call as positive and negative, that is the A single bond, B and A is positive, here it is negative, means resonance is possible. Just transfer the negative charge, isn't it? Now in this case if you resonate, the lone pair of electrons shifted here, and after that the resonance is like this: CH3 CH double bond oxygen single bond CH3 single bond CH3 पॉझिटिव्ह चार्ज न्यूट्रलाइज झाला इथं आणि ऑक्सिजन जो आहे इट कम्स पॉझिटिव्ह सेकंड स्ट्रक्चर. So in first case if you observe, if your numbers are given 1, suppose just for the sake of convenience I give number 1, 2 and 3 carbon atoms only, not the concept of nomenclature here considered. Second carbon carries positive charge, and if you observe the octet, isn't it, the second structure there is an incomplete octet. Why? Because there is only 1, 2, 3, 4, 5, 6 electrons. But if you consider in this case the octet is complete and oxygen carries positive charge, electronegative carries positive charge, no matter about that. So in this case first is more stable than second. So this is the point. Then molecules, that is the fourth point, that is molecules with negative charge on electronegative atom and positive charge on electropositive atom are considered as more stable than vice versa. That is resonating structures with negative charge on electronegative atom and positive charge on electropositive atom. If like this situation is there, it is more stable than vice versa. In the sense, negative charge on electropositive atom and positive charge on electronegative atom, अशी जर सिच्युएशन असेल तर तो काय असणार आहे, लेस स्टेबल असणार आहे. दॅट कॅन बी कन्सिडर्ड लाईक दिस एक्झाम्पल. जस्ट टेक वन एक्झाम्पल. दॅट इज अ केस कन्सिडर करूया आपण. डबल बॉन्ड लाईक दिस, सिंगल बॉन्ड A, double bond B, C have. Here last case there is a oxygen, isn't it? If you consider like this structure, here lone pair of electrons. Now in this case structure stability condition is satisfied. A double bond B, C have multiple bonds. If I resonate this first structure, if I resonate, how it is resonating? Yes, it is resonate like this. Suppose here this bond is shifted here, at the same time this bond is shifted here, this bond is shifted, oxygen becomes negative in the sense like this. Sorry, just like this. Here one bond, that is hydrogen is attached. Suppose in that case hydrogen is attached. You just shift, oxygen becomes negative, and this becomes double bond, and here this carries positive charge. This carries positive charge. It is overall clear, isn't it? It is second structure. It is second structure. Now in this case, it is charge separated is neutral. Charge separated is neutral. Obviously, it is more stable. But in this case, here electronegative carries, oxygen carries negative charge. But if I resonate like this, instead of going this like this situation, if I move, the pi bond between oxygen and carbon is shifted here, and this pi bond shifted on carbon atom. Then structure is, yes, like this. Double bond is there. Here negative charge, and this oxygen carries now positive charge. Oxygen carries now positive charge. This is third structure. No doubt, our first condition is that neutral molecules are always more stable. So first is more always stable in comparison with second and third. But here criteria, there is a second and third. Which one is more stable? Because one negative, one positive, one negative, one positive. But see, so the charge present, negative charge is present on electronegative and positive present on electropositive. That condition is more stable according to that. That's why second is more stable than third. And if I arrange the sequence, first, second, and third. First, second, and third. Okay. So this is the next concept. It is the electronegative atom on negative charge on electronegative atom is, and positive charge on electropositive atom. The next concept. That is the similar charges in resonating structure. During writing resonating structure, the similar charges if present, if present on adjacent कार्बन ॲटम्स, एकाच प्रकारचे दोन जवळच्या कार्बन ॲटम्सवरती सेम चार्जेस, सिमिलर चार्जेस असेल तर लाईक दिस स्ट्रक्चर्स आर इनसिग्निफिकंट. असे स्ट्रक्चर्स काय असणार आहेत? इनसिग्निफिकंट, म्हणजेच लेस स्टेबल असणार आहेत. म्हणजेच काय असणार आहेत? लेस स्टेबल. अँड दॅट कॅन बी अंडरस्टूड बाय कन्सिडरिंग एक्झाम्पल. सपोज डबल बॉन्ड, सिंगल बॉन्ड, and I think we have to take the example of nitrogen, NO2 group, N oxygen, and here double bond, and this oxygen carries negative charge, this oxygen, isn't it? This is first structure. That is first structure, isn't it? Here lone pair, I show it, lone pair. Now first case of resonance, first case, nitrogen is positive charge, nitrogen is here positive charge. First case resonance is A double bond B C have positive charge as well as multiple bond. So in that case, जर कॉन्जुगेट पोझिशनला मल्टिपल बॉन्ड असेल आणि त्याचबरोबर त्याच्यामध्ये पॉझिटिव्ह चार्ज असेल, निगेटिव्ह चार्ज असेल, फ्री रॅडिकल असेल किंवा लोन पेअर असेल, तर इन दॅट केस कन्सिडर ओनली मल्टिपल बॉन्ड्स, isn't it? That's why here shifting is like this. Suppose if I shift here, then it is shifted in this way, and resonance is like this. Nitrogen, there is oxygen, single bond oxygen, making this oxygen is also negative. It is positive still because the bond is shifted here and it becomes positive. Correct? हा बॉन्ड इथं आल्यामुळे हा पॉझिटिव्ह झाला, इथं बॉन्ड आला, आणि नायट्रोजन ऑक्सिजनमधला बॉन्ड ऑक्सिजनवरती गेला, त्यामुळे ऑक्सिजनला निगेटिव्ह केला, लाईक दिस. इट इज सेकंड स्ट्रक्चर. So instead of by movement this arrow like this, but instead of this, if I move the charges, or pi electrons like this, then third structure is possible. How? Yes. So just move the electrons like this. If A double bond B C have multiple bonds like this, if I move, it becomes here, and then structure becomes like this. Nitrogen here, oxygen negative, nitrogen still positive. Here instead of double bond, it becomes single bond, isn't it? And nitrogen, this carbon becomes double bond, this carbon becomes negative, and oxygen चा electron गेलेला, that's why it is positive. It is third structure. No doubt the first structure is, if you consider in first structure the charge separation, charges जे आहेत ते पहिल्या स्ट्रक्चरमध्ये दोनच चार्जेस आहेत बघा, एक पॉझिटिव्ह एक निगेटिव्ह आहे. आणि दोन जवळच्या ॲडजसंटवरती सिमिलर चार्जेस आहेत का? नाही आहे. एक निगेटिव्ह एक पॉझिटिव्ह, इट इज डिसिमिलर चार्जेस आर देयर. इन सेकंड स्ट्रक्चर नाव सी, हिअर पॉझिटिव्ह हिअर निगेटिव्ह, पॉझिटिव्ह हिअर निगेटिव्ह. Here if you consider negative, positive, positive, negative means this positive, positive, similar charges. So this condition, due to this criteria, due to this such criteria, this such type of condition makes that molecule more unstable, because similar charges is present on adjacent carbon, adjacent atoms, not carbon, not necessary, on adjacent atoms it is insignificant. That's why if you observe the stability order like this, if you observe the stability order, it is like this. So first is more stable than second, second is more stable than third case, isn't it? Now if you consider the next point, that is in checking the stability of molecules, in checking the stability of molecules, if you consider the next points, then next points we will consider the molecules or resonance structure with linear conjugation and cross conjugation. That is the linear conjugation, linear conjugations असा स्ट्रक्चर असेल, इट इज मोर स्टेबल दॅन क्रॉस कॉन्जुगेशन. Linear conjugation is more stable than cross conjugation. Now, what is linear conjugation and cross conjugation? Now see here. Just I take examples of both linear and cross conjugations and we will arrange. Now see here. This is an example, isn't it? Now see here. What is the condition? Now see here. If I considering the resonating possibilities, now see here. A double bond B, C have negative charge, isn't it? A double bond B, C have negative charge, or A double bond B, C have multiple bond. A double bond B, C have multiple bond. A double bond B, C having multiple bonds means actually A B. Suppose either make C here. Suppose in first case A double bond B, C have multiple bond. A double bond B, C have multiple bond. हे दोन जे आहेत डबल बॉन्ड्स ए बी ह्या सीला एका कॉन्जुगेट पोझिशन जे आहे त्याच्या कॉन्जुगेशनमध्ये आहेत. ॲट द सेम टाईम इफ आय मेक हिअर सी बी डबल बॉन्ड ए सी निगेटिव्ह, बी डबल बॉन्ड ए सी निगेटिव्ह, ह्याला पण कॉन्जुगेशनमध्ये. बट दीज टू कॉन्जुगेशन्स किंवा हे जे दोन डबल बॉन्ड्स आहेत, हे दोन डबल बॉन्ड्स आहेत, हे एकमेकाच्या कॉन्जुगेशनमध्ये येत नाहीत. तर असं जी सिस्टीम असणार आहे की दोन कॉन्जुगेशन्स किंवा दोन कॉन्जुगेट पोझिशन्स तिसऱ्या एका कॉन्जुगेशन पॉईंट्सबरोबर डायरेक्ट रेझोनन्समध्ये आहेत, पण स्वतः ते दोन पोझिशन्स एकमेकाच्या डायरेक्ट कॉन्जुगेशनमध्ये येत नसतील. सच टाईप ऑफ कॉन्जुगेशन्स आर कॉल्ड ॲज क्रॉस कॉन्जुगेशन्स. सच टाईप ऑफ कॉन्जुगेशन्स आर कॉल्ड ॲज क्रॉस कॉन्जुगेशन्स जर येत नसतील तर. आणि जर असा विचार केला येतो निगेटिव्ह चार्ज, isn't it? Like this, if I observe OH plus, now see here, here A double bond B C multiple bond, A double bond B C multiple bond, A double bond B C negative charge. म्हणजे ही पोझिशन आणि ही पोझिशन ही A double bond B C निगेटिव्ह, A double bond B C यांच्या कॉन्जुगेशनमध्ये आहे. बट ॲट द सेम टाईम they are also in conjugation with each other. हे दोन्ही पण एकमेकाचे काय आहेत कॉन्जुगेशनमध्ये. सच टाईप ऑफ कॉन्जुगेशन आर कॉल्ड ॲज लिनियर कॉन्जुगेशन. आणि लिनियर कॉन्जुगेशन इज मोर स्टेबल ॲज कम्पेअर्ड विथ क्रॉस कॉन्जुगेशन. लिनियर कॉन्जुगेशन इज मोर स्टेबल दॅन क्रॉस कॉन्जुगेशन्स. Then next, that is the, if you consider the resonance structure with equivalent जर असतील तर इक्विव्हॅलंट स्ट्रक्चर्स आर ऑलवेज मोर स्टेबल दॅन अदर्स केसेस. म्हणजे दोन स्ट्रक्चर रेझोनेटिंग पॉसिबल आहेत तर ते जास्त स्टेबल असणार आहेत दुसऱ्यापेक्षा. बेस्ट एक्झाम्पल देता येईल. समजा सपोज पॉझिटिव्ह हा केस आहे ह्याचा रेझोनन्स जर करायचं म्हटलं, ह्याचा रेझोनन्स, तर हा मल्टिपल बॉन्ड शिफ्ट केला, हा डबल बॉन्ड आणि इथं पॉझिटिव्ह. सो फर्स्ट अँड सेकंड ओनली 2 रेझोनंट स्ट्रक्चर्स आर पॉसिबल. सो द कॉन्ट्रीब्युशन टू द रिअल स्ट्रक्चर इज मोर. दॅट्स वाय सच स्ट्रक्चर्स आर मोर स्टेबल. जर ज्या केसमध्ये रेझोनन्समध्ये 2 आणि 2च स्ट्रक्चर तयार होतात, इक्विव्हॅलंट स्ट्रक्चर, इक्विव्हॅलंट स्ट्रक्चर म्हणतात याला. इक्विव्हॅलंट स्ट्रक्चर म्हणजे जो डबल बॉन्ड आहे, जो डबल बॉन्डेड कार्बन आहे, तो कार्बन डायरेक्टली पॉझिटिव्ह कार्बन अटॅच आहे. इथं पण तो डबल बॉन्डेड कार्बन आहे, तो डायरेक्टली पॉझिटिव्ह कार्बन अटॅच आहे. Such structure contribution is more to the real structure. Such a contribution to the more to the resonating structures. Okay. The next something that is the stability is more if the conjugation is increases. Length of conjugation increases. जर length of conjugation वाढत गेली तर त्या केसमध्ये जास्त असणार आहे. डबल सिंगल डबल सिंगल डबल जर कन्सिडर केला आणि ह्याच प्रकारे समजा एक दुसरी केस घेतला, दर इज द सेम कार्बन, दर इज द डबल and like this, suppose here double bond, here double bond. Now here alternate double single double single double single is more, but here double bond single bond but there is a gap, double bond single bond but there is a gap. So resonance is more in this case, resonance is less. So this is more stable, this is more stable, isn't it? Now one more point you would remember that the if aliphatic and aromatic जर consider केला, that is the suppose 6 कार्बनची ॲरोमॅटिक रिंग, 2 3 4 5 आणि 6 डबल सिंगल डबल जर कन्सिडर केला तर इथं पण 3 सिंगल 3 डबल 3 सिंगल 3 डबल. सो इन दिस केस ॲरोमॅटिक इज ऑलवेज मोर स्टेबल. ॲरोमॅटिक इज ऑलवेज मोर स्टेबल. वन मोर पॉईंट दॅट इज द ऑल रेझोनेटिंग स्ट्रक्चर्स. जेवढे रेझोनेटिंग स्ट्रक्चर्स असतात त्या सगळ्या रेझोनेटिंग स्ट्रक्चरमध्ये जे ॲटम्स पार्टिसिपंट असतात त्या ॲटम्सचं हायब्रिडायझेशन स्टेट जे आहे, हायब्रिडायझेशन स्टेट, that state of hybridization is almost same. स्टेट ऑफ हायब्रिडेशन जवळपास सगळ्यांचं काय असतं, प्रत्येक वेळेला बदलत नाही, तर ते काय असणार, सेमच असणार. फॉर एक्झाम्पल इफ यू कन्सिडर द स्टेट ऑफ हायब्रिडायशनचं एक्झाम्पल, इथं बघा पॉझिटिव्ह, इथं पॉझिटिव्ह घेतला आणि समजा हायब्रिडायशन केलं लाईक दिस, पॉझिटिव्ह निगेटिव्ह. all the atoms in this case are in the sp2 hybridization. all the atoms in this case are in the sp2 hybridization. सगळे ॲटम्स जेवढे आहेत ह्यातले आणि ह्यातले पण, म्हणजे जेवढे रेझोनेंट स्ट्रक्चर तयार होणार आहेत त्या सगळ्या रेझोनेंट स्ट्रक्चरमध्ये पहिल्या केसमध्ये जेवढे हायब्रिडाइज्ड स्टेट्स ॲटमचे होते तेच प्रत्येक केसमध्ये असणार आहे. जस्ट चार्ज डेन्सिटी जी आहे ती मूव्ह होत असणार आहे, इजंट इट? सो स्टेट ऑफ हायब्रिडायशन रिमेन्स सेम. स्टेट ऑफ हायब्रिडायशन रिमेन्स सेम. आणखीन एक स्ट्रक्चर पॉईंट सांगता येईल की 2 डिसिमिलर स्ट्रक्चर जर असतील, 2 डिसिमिलर स्ट्रक्चर्स, तर त्यांचं कॉन्ट्रीब्युशन हे वेगवेगळे किंवा कमी जास्त प्रमाणात असतं रिअल स्ट्रक्चरमध्ये. दॅट कॅन बी एक्सप्लेन्ड बाय टेकिंग अन एक्झाम्पल, सपोज लाईक दिस, अँड सपोज हिअर डबल बॉन्ड CH2, isn't it? So in this case, if I take examples to single and double bond CH2 and yes, 1 2 3, and positive charge is here, suppose, okay, then this structure, in this structure, if resonance is there, A double bond B, C have positive charge, A double bond B, C have positive charge. But in this case if I make resonance like this, if I made resonance like this, then like this, here single bond and double bond, here single bond CH2, it is plus. In this case these are the 2 dissimilar structures. So contribution to the resonance is the structure which has more stability contributes more to the resonance hybrid, and the structure with less stability contributes less to the resonance hybrid. So out of these two structure first is more stable, so its contribution to the real structure is more. This is less stable, so due to less stable, its contribution to the real structure is less. But इक्विव्हॅलंट स्ट्रक्चरमध्ये तसं होत नाही. इक्विव्हॅलंट स्ट्रक्चरमध्ये काय होणार, पॉझिटिव्ह. इक्विव्हॅलंट स्ट्रक्चरमध्ये काय होणार, लाईक दिस पॉझिटिव्ह, हिअर पॉझिटिव्ह. So these two structures are identical, and as structures are identical, therefore there is an equal contribution in the resonance. One more point. If the sigma bond is present, if sigma bond is present, suppose, and if there is a free rotation, there is a free rotation, but due to, if this sigma bond by reason, if it comes in conjugation, with double bond, then ultimately that sigma bond, single bond character is converted to double bond character. So in that case, the free rotation about that carbon is not possible. Okay, so it is actual part of the isomerism. So up to this point, we consider the stability of different resonating structures. So it will help to understand the reactivity and stability of carbocation, carbanion, etc. So in next lecture, we see the next point, that is a mesomeric effect. Okay, good day.